All right, we've talked about translations. The focus of today's video, reflections. So a reflection is a transformation that uses a line like a mirror. Kind of makes sense. Reflection, mirror, like, okay, we got that. We'll call that mirror line the line of reflection. So if we're going to do this from P to P prime, we need to have an idea that the distance between P and the line of reflection and P prime and the line of reflection, that has to be the same. So those have to be congruent. And the idea needs to be that it's a perpendicular relationship, right? That almost you can reflect over any line, and I always kind of say like the easiest way to think about it is if you like rotated this thing, okay? Would they be like right above and below each other, right? Because that's what you'd want a reflection to be. So that applies even on like a diagonal. You'd want them to be right above and below each other. So it's not like down here. That's not a reflection. It actually needs to be like directly across, which makes it perpendicular. So those are the things that um, make up a reflection. So here we have some examples. All right. The easiest ones are vertical and horizontal. So if I ever make you go over something that isn't one of the axes, I promise it'll be like just over a line like this one, y equals 1, or this one, x equals 3, where all you really need to do is count your way over it. So if this is A and it's 1, 2 away from the line, then I'll go another 1, 2, and there's my A prime, right? If I look here, okay, I'm 1 unit away, so I'll go 1 unit away. I would not make you, we're not going to do reflections over a diagonal other than y equals x, which is like your 1 up 1 over 1, or y equals negative x, which would be just the negative version of that. We'll cover those in just a moment. So if we look at this right here, we can reflect anything. We can reflect segments, we can reflect shapes. And we want to be aware of slopes, right? Opposite reciprocal slopes. That's what it takes to be perpendicular. And opposite reciprocal means, like a good example of it is that negative 1 over 2 turns into 2 over 1. Things like that. So if I have y equals x, the opposite of that would be negative x, right? That's the slope of 1. The opposite reciprocal is negative 1. So here I can see that the green line is going up 1 over 1, up 1 over 1, and then this is down 1 over 1. Great. Down 1 over 1, down 1 over 1, down 1 over 1. Great. So we can see how the slope can also, it's harder on the diagonal. We can't really just count our way over, but we can use this slope. But there's also rules that we can just kind of piece together here. And this is stuff where we did this activity yesterday where I wanted you to see, hey, on your own, reflect over the x-axis, reflect over the y-axis, and see if you can kind of make a prediction on these rules. So when you have a slope, or sorry, when you have a coordinate plane and you've got a triangle like this and we're going to reflect it over, so now it looks like this, what you'll notice is that every single xy point, the x hasn't changed, right? Which kind of makes sense intuitively. You're like, yeah, this point is still in the same line as this one. This is in the same line as this one. This is in the same line as this one. So what's the only thing that changed? The y value. And don't get tricked into seeing that as, oh, it became a negative. That's not it. It became its opposite, right? Because you could start here. You could start at 2, negative 2, and reflect up to 2, 2. You still went from negative 2 to positive 2. That is, you're just becoming the opposite. So let's keep applying these rules here. Right? The reverse would be if I'm going horizontally, if I'm going from here and I'm going across, I'm staying at the same height, right? So my y value will stay the same. What changes is my x value. It will become the opposite. And then the diagonals, y equals x, y equals negative x. So that's, you have this coordinate plane. and you've got this diagonal, y equals x. If I gave you a point up here, like 1, 5, well then, the opposite reciprocal of that, or sorry, the reflection of that is 5, 1. We flip it around. Let's talk about y. Let's see. This is supposed to be a slope of 1. So does down 1 over 1, down 1 over 1 get me to this reverse every time? It does. Right? Down 1 over 1, that next step would be 2, 4. Down 1 over 1 would be 3, 3, which is right on the line. Yep, that makes sense. 3, 3. 3 equals 3. It's on y equals x, so that totally works. Down 1 over 1 more time to get to, or sorry, almost one more time, to get to 4, 2, and then down 1 over 1 to get to 5, 1. So you go, okay, that rule does work every time. And then it's the same, if you're doing y equals negative x, it's just, you turn it around and you make them the opposite. Turn them around and you make them the opposite. Which kind of makes sense, because if you're like in a situation where going this way, if I'm over here, I'd reflect onto this side. So if I'm at 4, 4, right, I'd wind up down in this area, which is not just, switching it around. Oh, I probably shouldn't have picked the same points. What a terrible example, But we'd wind up in this quadrant, which is, as we know, negative x's and negative y's. So that's kind of your summary. All right. At this point, we're good to jump into some examples. It makes sense that a reflection is an isometry. We're not dilating. We're not changing the organization. So we're going to jump into practice, right? Where I'm hoping you'll go, okay, y-axis, that means what am I changing? The x value. So here I am at 3, 3. So to reflect that, I just need to be at negative 3, 3. If this is 5, 1, then I just need to be at negative 5, 1. And that's 0, 0, so that's not really going anywhere. And I go, does that look like a reflection over the axis? It sure does. Sure does. Right? Reflecting the x-axis, this is a good example of how things start getting more difficult, where like, we're on both sides. So these two guys aren't going anywhere. This one just needs to come down here. This needs to go up here. And I can still connect with those same points. Boom, reflection. And then we got the diagonals, y equals x, so I gotta flip-flop everything. So if I'm gonna go over this, and this point is negative 5, negative 3, now I'm gonna be at negative 1, 2, 3, negative 1, 2, 3, 4, 5. I'm gonna be right here. If this is negative 4, negative 3, then the opposite would be negative 1, 2, 3, negative 4. And if this is negative 5, negative 1, then the opposite would be negative 1, negative 5. And that's our reflection over the diagonals. The diagonals are harder. But there you go. That's a wrap. And I hope this video helps. We'll do a bunch of practice with it.